Hello guys, today I'm just making a video on some basic insights on how to solve questions related to the topic moments, levers, and gears. I know many of you guys have this topic coming up for exams, so I thought hopefully this video can help you all in order to solve these type of questions. By the way, if you guys want to see the questions more clearly, you guys can do that. You guys can change the quality in the YouTube settings of this video so that you guys can see the questions more clearly, and time codes will be in the description box below so that you guys can skip to any questions you guys like. By the way, this website is taken from the site Physics and Math Tutor, a very good website to learn other subjects as well. And if you all have enjoyed the video, please do like, share, and subscribe to the channel. It really helps a lot. And yeah, let's begin with the video. Alright, so the first question states that two children, A and B, are sitting on a seesaw as shown in the figure below. The seesaw is balanced, and you guys can use the following equation to calculate the moment of child B about the pivot of the seesaw. So you have to give your answer approximately in Newton meters. You guys can see that the moment of force formula is given to as force times distance, and we know that force is measured in newtons and that distance is measured in meters. So we have to convert this 90 centimeters as mentioned in the question to meters. So 90 centimeters to meters is going to be about roughly, let's say 90 centimeters to meters is going to be 90 centimeters divided by 100. You're going to do that to give you a value of about 0.9 meters. So now we're going to use this value as the distance. Always convert your values before substituting them into the formula. It's very critical. That tip is been used there. Alright, so you have moment is going to be equivalent to force 280 newtons times distance to be about 0.9 meters. It's going to be equivalent to 280 times 0.9, 252 Newton meters. So now this is going to be your value for the moment of the force for about, let's say, 2 marks. Alright, let's move on to the next question. Now the next question, we have to use the idea of moments to explain what happens when child B moves closer to the pivot. So what happens when, let's say, this child B moves closer to the pivot? So I've already written down the answer just to save up time. Is that the clockwise moment of child B indirectly, let's say, it decreases and making it less than the anti-clockwise moment. So this is the clockwise moment and this is the anti-clockwise moment, and which makes the anti-clockwise moment less of child A, so indirectly causing child A to move downwards and let's say child B to move upwards. Alright, let's move on to the next question. I think it should be more of like that. Alright, so the drawing shows a sign which hangs outside the shop. You guys can see that you have to draw an X on the sign so that the center of your X is at the center of mass. So the center of mass is just a point that where the mass is maybe thought to be concentrated at that specific point. So center of mass on the sign. So I think it's roughly about the center somewhere here. It looks like roughly. So if you draw like an axis of symmetry, it should be somewhere right at the middle of this. Basically the center of X is basically at the center of this concentric circles. So I'm just going to draw a nice X there. Basically we have to just draw it somewhat like that. Okay, now use a ruler to draw one axis of symmetry on the sign. So we can draw this axis of symmetry from any corner. So we can draw it from any corner to the diagonal opposite corner as well. It's an axis of symmetry. We can either split this about, so yeah, somewhat like this. This is technically one axis of symmetry, so that's also fine. Now, one force which acts on the sign is its weight. Complete the following sentence by drawing a ring around the correct line in the box. The moment of the weight produces a turning effect. You have to remember that moment is basically, here's a tip, is that moment is the turning effect of force. That's what moment means. And yeah, so you have, it's a turning effect of the force. Let's move on to the next question. Now the third question states that you guys can see that there's a spanner, which makes it a lot easier to loosen a bolt. You have to use these words to complete the sentences. Alright, so the spanner is a simple lever. Alright, then we use it to produce a bigger turning effect. That's going to be your answer there. Alright, and a longer spanner works better. This is because there's a bigger distance between your force and the pivot. So now this is something that you guys have learned down. is that the spanner, which is I think this device here, it increases the distance, indirectly increasing the turning effect and making it easier for us to move the bolt, or let's say losing a bolt in this case. Alright, so that's a total of about 3 marks. So let's move on to the next question. Now the next question shows us that there are 2 children that is visiting a playground. We have to complete the following sentences. Is that the turning effect of the girl's weight is called her moment. So we're going to circle that down. And point P is the axis of rotation. We're going to circle that as well of the seesaw. To make end A of the seesaw go up, the girl has to move closer to point P in order to do that style of movement of the seesaw going up. So the girl has to move closer to point P in order to make the seesaw go up, right? Now, in another part of a playground, the tire has been suspended from the bar. You have to draw an X on the diagram to show the center of X that marks the center of the mass of the tire. So it should be somewhere roughly about this. You can judge by the eye in order to solve this type of question. Now, if the tire is pushed, it will come to a rest with the center of mass directly, let's say, below the point of suspension. So I've usually seen this type of question being asked in some of the past papers. So do learn this, is that when something is suspended, it will come to rest with the center of mass, which will be directly below the point of suspension. That's a key point that you guys have to take down when dealing with these type of questions. Alright, let's move on to the next question. Now, the next question states that you guys can see that the diagram shows someone starting to lift the end of a heavy wooden pole. And we have to use this formula again. Let's use the formula triangle MFD, which just means that moment is equivalent to force times the distance. So you can see, check if all the values are correct. Force is in newtons, distance is in meters, so it's all okay. We're going to use it in our equation. So force, which is 500 newtons, multiplied by 2.5 meters, which is the distance. So you have 500 times 2.5 to be roughly about 1,215 newton meters. So this is going to be your answer, 1,215 newton meters. All right. Okay, let's move on. Next question. Now, the next question states that the smallest force needed to lift the end of the pole will be smaller than the weight of the pole. You have to give a reason why. The reason is because the force is because the force is exerted further from the axis of rotation than the weight. Alright, so that's your answer for about 1 mark. Let's move on to the next question. Now, the next question states that how could the person lifting the end of the pole increase his moment? In order to do that, you have to technically increase the force exerted. Alright, that's for 1 mark. You guys have to mention that point. Let's move on to the next question. Now, the next question, you guys can see that the student holds a ruler at one end and slides a weight along the ruler. You have to say at which point will the turning effect of the weight feel the greatest. So it's going to be at point C. That's your answer. All right, let's move on. Next question. Complete the following sentence. Is that the turning effect of a force is called the moment of a force. That's going to be your answer. And in a human arm, the biceps muscle provides the force needed to hold the arm horizontal. The student uses a model in which a rubber band represents the bicep muscle. So you guys can see that the rubber band represents the bicep muscles. To hold a small arm horizontal, pull from the rubber band should be bigger than the force caused by the weight. Alright, so the pull of the rubber band should be bigger than the force caused by the weight. Alright, let's move on to the next question. You guys can see that there's a long spanner and you're given the formula of moments. So you have to show clearly how you calculated moments. You're going to check the values. This is 12 centimeters. So we, like I said, we have to convert centimeters to meters. So we know that 1 meter is 100 centimeters. So 12 centimeters is going to be divided by 100 centimeters to give us a value in meters. It's going to be roughly about 0.12 meters. Alright, so you're going to use 0.12 meters as your, let's say, as your value for distance. Okay, so you have moment is going to be equivalent to force 10 newtons times distance 0.12 meters. Is going to be equivalent to 10 times 0.12. That's going to be about 1.2 Newton meters. Now that's going to be our answer, about 1.2 Newton. Actually, no, wait, hold on. Since this is 10 newtons, we have to check the value of, let's say, moment. So basically, we actually do not have to convert this. Actually, we can leave it as 12. Now, the reason why I'm saying we don't need to convert it is because we have to carefully look at the question. The question states that we have to calculate the moment in Newton centimeters. That's all. So basically, you can just leave it as 12 centimeters. So do read the questions below carefully just to analyze all this type of questions. So you have 10 times 12 to give you about 120 Newton meters, Newton centimeters. Okay, we're going to edit that part as well. So you have 120 Newton centimeters. All right, let's move on. Next question. Now the next question states that a company makes a wheel wrench with an extending handle. You have to use a force. You have to use the moment calculation again. So you have moment is going to be equivalent to the force in 250 newtons times the perpendicular distance to be about 0.3 meters is going to be equivalent to about, let's say, 250 times 0.3 to give you about 75 Newton meters. Since they're giving us the values in Newton meters, we're going to leave it as Newton meters itself. So you have 75 Newton meters. Okay, so that's pretty quick. Let's move on to the next question. Which of the following will be the unit of moment? Moment is going to be Newton meters. That's going to be your moment in this case. The wheel nut will not move, and the handle of the wrench is extended. So basically, how is it easy for it to loosen the wheel nut using the same force as before? The reason is because when the force is basically applied from the pivot, which will make the moment on the wrench larger. Technically, what I'm saying is that as you increase the distance, the moment will increase as well. All right. Let's move on to the next question. Now, the next question shows us a gardener using a steel bar to lift a tree stump. All right, so we have to calculate moment again. It's going to be equivalent to the forces given to us as 300 newtons. And the distance is going to be about 1.2 meters from the question itself. It's going to be equivalent to 300 times, let's say, 1.2 to give us a value of about 360 Newton meters. So that's going to be your answer for about 2 marks. So you have 360 Newton meters. Let's move on to the next question. Now the next question states that using a longer steel bar, as you guys can see, if we use a longer steel bar, it would have made it easier for the gardener to lift the tree stump out of the ground. You have to explain why. Now the reason why it is because the force is applied from the axis of rotation, which increases the force on the tree stump. Alright, so like I said, you increase the distance, moment will increase and the force will also increase as well. Let's move on to the next question. Next question is again about center of mass concepts, right? So you're going to have to draw an X on the diagram below so that the center X marks the center of the mass of the pendulum bob. So you can see somewhere about X there as well. I think somewhere center of X should be drawn as the center of the pendulum bob, okay? Yeah, the frequency of the swinging pendulum is about 0.5 hertz. If we calculate the periodic time of the pendulum, now this is a question that is kind of like, let's say you have to calculate using a formula for the periodic time. Now, in order to do that, you have to do is that the frequency, let's say the time period. So there's a formula called time period is going to be equivalent to 1 divided by the frequency. So that's going to be equivalent to 1 divided by 0.5 hertz. So that's going to give us a value of about 2 seconds. Alright, so 2 seconds is going to be your answer in this case. Calculating the number of complete swings the pendulum would make in 60 seconds. So it's going to be 60 seconds divided by 2. That is going to give you a answer, let's say, about like 30. I think it's going to be 30 swings in 60 seconds. Alright, so you're going to have 30 swings in this case. Let's move on to the next question. Now the next question states that the diagram shows a clock on a trolley. The trolley has been used to move the clock. Calculate the moment of the 64 Newton force about the pivot. So it's going to be moment is going to be equal to the force 64 newtons times the distance is roughly about 0.8 meters. So you have 0.8 meters again. We're going to leave it as Newton meters. So you have 0.8 to give you roughly about 51.2 Newton meters. So just from the question itself, you can find out certain values. So you have 51.2 Newton meters. All right, let's move on to the next question. Now the design of the trolley is now changed to make it taller, so increasing the distance technically. How does making the trolley taller affect the moment produced by the 64 Newton force? Like I said, if you increase the distance, it'll indirectly increase the moment. So you have to say it's going to increase the moment. All right, so it's going to increase the moment. All right, let's move on to the next question. Now the next question shows us a person that's standing on a diving board. You have to calculate the moment of the person's weight about point A. So you have moment is going to be equivalent to the force to be about 600 newtons times the distance is 5 meters. It's just going to give us a value of about 3,000 Newton meters. So this is going to be your answer. 3,000 Newton meters is going to be your answer. Right? So just take your values from the question itself. It's going to help a lot. Alright, so figure 2 shows the person standing at a different place. The diving board is not turning. The total clockwise moment is balanced. You have to buy the total anti-clockwise moment. Alright, so that's going to be your answer. Total anti-clockwise moment. Alright, let's move on to the next question. Now the next question shows an upward force of force varying with the distance from the person from point A. The upward force when the girl is standing at the distance of 3 meters. So the upward force is roughly, if you guess it correctly, should be, if you divide 1000 divided by, let's say, 5 squares, that is going to give you a value of about 200 newtons per square. So you have 300, so it's going to be about 3,400 newtons roughly, about 3,400 newtons roughly. So if you have 3,000 plus 200 plus 200, it's going to be 3,400 newtons. Alright, let's move on to the next question. What conclusion should be made from figure 3 is that as the distance, as we can see, as the distance increases, the force in newtons also increases. So as the distance of the girl from point A increases, like I said, as distance increases, the force as well, the force F, let's say, the force also increases indirectly. All right, so that's going to be for 1 mark. So you're going to say that as the distance of the girl increases from point A, the force indirectly also increases as well. Let's move on to the next question. Now the next question shows levers in hydraulic systems. You have to tick 2 points or changes that will allow her to lift the rock more easily. So 2 changes is that you have to make the rod longer and you have to push down on the rod with a greater force. That's the only way it's going to work. Now liquids aren't used in hydraulics systems because they're virtually incompressible. You explain how the spacing of particles in a liquid causes it to be virtually incompressible. So the particles are close together. That's going to be our answer because they have no room for more movement. All right, let's move on to the next question. You can see a man using a car jack to lift his car, and you guys can see that the man pushes with effort force that results in much larger force acting upwards on the car. Use the information from figure 3 to explain how. All right, so as the downward force produces pressure in the liquid, which is the same pressure basically at all points in the liquid, you're going to say that the area of the load, which is bigger, is going to make the force bigger as well, right? As the pressure increases, you're going to say that the area of the load gets bigger, which makes the force bigger as well. For 4 marks, you guys have to state 4 good reasons why, as the man pushes down with effort force, it results in a larger force acting upwards on the car, all right? Okay, which of the following statements about the forces in figure 3 is correct? Is that the force, okay, let's check figure 3 again. Force acting on the car, effort force from the person, and you guys can see the liquid. Is that, tick 1 box, you can say that the force acting on the car, let's say it moves a less distance than the effort force. So you guys can see that the force acting on the car moves less distance than the effort force. All right, so moves less distance than the effort force. All right. So this guys, this seems to be the end of all the questions. If you guys have enjoyed the video, please do like, share, and subscribe to the channel. It really helps a lot. And do comment below on what your thoughts are on whether I should continue solving questions related to past papers or topic by wise questions. And yeah, new content will be posted soon. And I think that's it, guys. Alright, bye, guys.